Okay, question 2. A screening test for Jones syndrome, which is transmitted to sixth form maths students, gives a positive result with a probability of 0.92 when a pupil has the syndrome. When a pupil is being tested does not have the syndrome, the test gives a positive result with a probability of 0.03. It's known that 5% of the sixth form maths students suffer from Jones syndrome. The test is given to a randomly chosen member of the sixth form maths population. Find the probability that a positive result is obtained. So with this one, what you need to get clear in your head is which order things happen. And the order that they happen is that they either have or don't have the syndrome, and then they are tested. So the first branches are going to be have syndrome, don't have syndrome. So have syndrome, don't have syndrome, 5% suffer from it, so 95% don't. So that's the person being selected, then they're going to be tested. When a pupil has the syndrome, a positive result is 0.92. So a not positive result is going to be 0.08, because those two have to add up to 1. If they don't have the syndrome, you may still get this false positive of 0.03, which means you've got a 97% chance of not having the syndrome. So the probability of a positive result will either be from having the syndrome and positive, so S and P, or not having the syndrome and positive. So those are two different outcomes that would achieve a positive result. So that will be 0.05 times 0.92 plus 0.95 times 0.03. So 0.05, 0.92, or 0.95 times 0.03. So that's going to be 0.0745. B. Given that, so we're in conditional probability land, given that a positive result is obtained, find the probability that this person has the syndrome. So probability, syndrome, given, positive. So using the formula, that's going to be probability of having the syndrome and positive over probability positive. And usually with these conditional probability questions, part of this work is already done in a previous part of the question. You can see here we've already calculated that denominator, the probability of being positive. Probability of having syndrome and positive will be 0.05 times 0.92 divided by your answer to part A. So 0.05 times 0.92 over 0.0745, 0.6174. And then part 2, what makes this challenging is you need to read the question really carefully. A negative result will be obtained if a second test is given to this person. So this person, we've calculated that the probability that they have the syndrome is 0.6174. So the syndrome, not syndrome part of this changes, because this person has got the chances of 0.6174 having the syndrome. So if we then take that away from, we got a fraction there, take that away from 157 over 149.38255, and then the testing is going to have the same probabilities as it did before. So positive, negative, positive, negative, 0.92, 0.08, 0.03, 0.97. So a negative result for this second test will be has syndrome and negative, or doesn't have syndrome and negative. So that would be 0.1674 times 0.08, or this bit 0.38255 times 0.97. So I've got that 0.38255 on my calculator already, so I'll multiply that by 0.97. I'll add to that 0.6174 times 0.4205. So that question, straightforward enough for the first two bits. The second part, the final part, it's actually getting your head around what is happening here. So this person in the first test had a positive result, and the chances of them having the syndrome is that. So the first branch for the second test is has the syndrome, doesn't have the syndrome. We're still talking about probabilities, and then we branch from there. So that last 2 marks, there's the trickiest bit.